Hello, I'm going to start my MHN7 honeypot presentation. The MHN7 was running for 24 days in total from the 11th of October to the 19th of November. During this period, I was able to gather 80 million, almost 90 million events. The MH server crashed along the way, and it was due hardware configuration. I needed to increase the specs on my machine in order to avoid the issue. The sensors that I deployed was Amun, Comport, Colride, Ionair, Elastic Horn, Poof, Shock Port, Snot, and Word Port. I divided the sensors in two groups, and I tried to cover all the locations around the globe, at least Europe, America, and Asia. I did created 10 droplets, 10 cloud virtual machines, nine for the sensors, one for the MHN server. This presentation want to be a PowerPoint presentation. I want to do a live demonstration of what I had achieved, pretty much everything. So let's start to play with the analyzer. I do have plenty of tabs opened because if I try to refresh all of them, I would get an exception that I cannot do multiple searches at the same time. Something that I would like to highlight is that I did achieve the possibility to shut down the sensors, the dashboards related to some sensors. So once I shut down that, the information will no longer appear, and it could help me to narrow down if I want to have just correlate specific informations. So in here I already have one IP. This IP it's from Dublin. This shield would tell me that is Amazon instance, and we can see that the attacker tried all my sensors in pretty much all the locations. We can see that he made connection to honeypot few times actually, and we can narrow down by when he started to have connections and what time. We can see that he was rejected sometimes, and we can see going down, you can see all the ports that he exploited. So we have 22, 21, 23, 80. We have all the ports in here listed. We have the SSH connection, not version. This JSHC, it's related to a Java application that performs SSH2. So it could give us a lead that he was trying to do some enumeration related to the Javas. He was trying to fingerprint or understand, So we have these enum algos. This pretty much is a nmap script that would enumerate all the encryptions and the compression algorithms used by the server itself. This Rapid7 SSH for me, it's unknown. I did have an agent Rapid7 installed on the machine itself. I don't know if he tried to exploit somehow. We can see that he did try to brute force, and you can see all the commands attempted by the sensors. We can quick study his behavior by reading the Elastic signature. So you can see that he tried to scan the ports related to VNC. We can see that he tried to scan the SSH. He attempted to log in on Colride, and we can see that the attempt would be the brute force itself. We can see that he ran unknown commands, and we have everything detailed in here. Going even further down to page 10, we can see that he did a session, so he was able to brute force, and he tried to do lots of reconnaissance. he was using the Linux version 222. He did use Ethernet modem, and 8 times he used the VPN. So the not signature also highlights almost the same, and it gives a bit more information for us. So for example, if we can see the potential VNC scan on those ports, we can see RPC XDMCP info query that it's related to attempt to query the X display manager control protocol. I'm sorry. We can see that policy PC anywhere that indicates the application violates some corporate security policy. We can see the attempt to fingerprint the ports related to SQL or MySQL itself. SNMP public address. He was trying to exploit the SNMP version 1 that could cause denial of service and gain privileges. He tried to SNP attempted on Cisco device. So also it would allow to gain access on Cisco pretty much. We do have more ports fingerprinted in general, and there is something that it's interesting here, that is scan. Let me just go back. Scan behavioral unusual fast terminal service traffic. I did took a while to understand what it meant. So I came back to the server itself. Then I saw the command show version all. These commands are related to Cisco devices, and my machine was a Linux one. So this snort signature pretty much said that it wasn't a person typing all those commands. It was a script that the person was trying to fingerprint and get all the information. And if the command would fail, it means that it's not a Cisco. So whenever he starts to have commands related to Linux used, he just followed that. So you can see here that he's trying to, let me just see. He's still trying his show running config. Should be something related to Cisco, but he has some comments that it's related to Linux in general. So we can see here all these attempts. There is one specific command that I would like to see. Let me just click in search for we have a better view. I did try to make the dashboards beautiful, so I have a limited vision. So for example, this command in here is try to find everything using try to use all the file system types. So we have NFS, we have SMBFS. So it's a script that's trying to find and trying all the possibilities. So this is the behavior of this attack, and I wouldn't be able to correlate all the informations without to create my personalized dashboards. So let's see another examples in here. We have 3 minutes left. So I'm just gonna get one IP, and we have the, so this attacker, again, I can use this shield integration, and it's from Argentina. If I needed to take any measures against this attacker or try to notify the guard, the police, I could be able to also notify the company that provides service for this person and say that he's doing some illegal activities. So we have a moon sensor, the on-air sensor. So here we have here the time chart. I can double check. So the 14th at the same time. So matches. We can see that he was accepted. Again, 14th and 11th and 11th. So everything it's correlated. We can see it's not signature, and we can see that this guy did exploit the port 445. He did a connection to honeypot, and he might have used try to inject a malware, And we can see that, yes, it looks like it's a Winter 2 Trojan, and port 445 is Sif's port that the Windows use to connection. So it would make sense that some malware for Windows devices. So again, let me get another IP. So he tried to exploit my Core. We can see the location Frankfurt. Then you can see that he pretty much just tried once in one day. We can see here, so 29, 29. We have the, so we can see that he tried to brute force, and he tried to URL download attempt. So he tried to download something that we can see here, that he tried to download doors being sh, so some sort of script, and the command is actually huge. So it's one line with a huge command that we have here, and we can see all these not signatures that almost that they almost matches with the exploit. We have four. Sometimes it's not. It's able to capture more information. So we have SSH login, SSH session, command attempted, and download attempted, and both matches. Sometimes, like the first example, we had more signatures for it's not. If the requirements to understand the behavior, I could not rely on the Mhn Splunk app that we have right in here. I needed to create my own dashboards that I could filter the information the way I wanted by the sensors, and include the unique values that sometimes the modern neural network did not have. So for example, this is the chloride that I have created. We have at the top in all my sensors that I have created almost the same information, that it's basic information, that we have counters by source attacks, sensor location. If you have the app itself, chloride in lots of locations, and the the top 10 attackers, they, but this is not interesting for now. So I want to focus first on those two time charts. Both they show the same information. Here you can see just in a table that's, for me at least, it's easier to read and understand. So we have here attempt to gain access and the SSH session. We have the brute force passwords that were used by sensor. We have all the commands executed, and we have the files downloaded. Something that I would like to show is I try to do everything friendly user. So if you can see that my sensors, they have the name of the location where they are installed, instead to have the sensor ID, what would make it hard to understand. You would need to filter and double check if that combination of numbers means, for example, Amsterdam. So I try to do this in all my sensors, and I did achieve, a very user-friendly interface. The files downloaded, I did create two extra fields, wget and curl, that modern MHN app on Splunk did not have. Splunk has this functionality that you can create fields from anywhere. So pretty much is what I did. Otherwise, this table would have just the command itself, and I would look exactly like that. That is the one that has the command. So something that is interesting on my dashboards, that I have the capability to filter anything that I want. So in this example, I can filter by location, by date, as you can see in here, and I can filter by IP. So let's see what happens when I click in IP. I can see the location, that the sensor location, the SSH version used, and I can see, for example, this guy tried to brute force. We can see all his attempts, and it's just one sensor, and you can see the command that he ran. How the command has this word wget, it will show twice, and we can see that he did run some sort of script, and this script probably it's a payload. Uh, we can see the attempt to gain access. I have the analyzer dashboard that I will spend more time, so I'm just trying to be short in here. So Dionaea also have all the same top informations. We have the map that looks nice, but the most important here are the port numbers, the MD5 signatures, and the time shot connection that reject, connect, and accepted. I also was able to replicate from the modern the MHN server the D-Shield integration and the virus total integration. So I can just pretty much click and see the information from the shield and the virus total information if I wish. I can filter by IP as I have showed, and I can filter by port number. So I'm just gonna try to change for port number, and we're gonna see that everything will populate according to port number 445. So you can see that most of the malwares was designed to this port. And we can see that everybody that tried the port 445 was accepted. So if I change back, I can see just the reject connections, and again, the basic information in here, and all the ports that rejected the connection. So poof, also we have the connection made, what the attacker used, which connection that the person was used, Ethernet mode, VPN. We do have the port numbers as well. We have the OS. Again, I can filter by port number and IP if I wish. We have the snort. Snort has its own signatures and the ports, so it's very useful for narrow down the behavior of each each attacker. So Alaska Honey also have the payloads. That's something interesting. And when we start to enter IPs, we can see more of the signatures that Alaska Honey is able to capture. Also, you can see the URL requests, and I did create a dashboard for that. Amun, we have the Amun connections, the port. Both are the same information. It's just easier to read if you want, because you can narrow down by date and exactly by time. So Compot also have the shell shock exploited attempt, and we can see the basic information. So Shockpot also we have the the shell shock exploited attempt, and the word port we have the signatures of attempt to exploit, scan, or enumeration. Again, for example, word port is WordPress honeypot, so it makes sense that we can see that the WP login was exploited, or at least suffered attempts to be exploited. Once this would be the login page. Each sensor has its own values, and sometimes just look at that, it doesn't seem to be much. However, if you are able to integrate all the unique values that each sensor can provide, you can filter everything and see all the behavior that the